Saxon Math Course 2. We are on Lesson 27. Lesson 27 deals with basically the idea of what's called least common multiples. And you see I've underlined the LC and the M and given it an acronym of LCM. Least common multiple of a number is if you have two numbers and it's what they have as a common denominator. So let's use the number 4. What are multiples of 4? Well, if we started by 4 and started counting by 4s, we'd be 4, 8, 12, 16, 20, 24, and so on. What if we used the multiples of 6? We'd go 6, 12, 18, 24. All right, and on and on and on it goes. Are there common multiples where there's a 4 here but there's no 4 in 6? Same with the 6. There's no 8. Look at this. Here's 2 that are common. And then, hey, here's 2 that are common. And you'll notice a link between 12 and 24 and 12 and 24. So we would expect that the next 12, which would be 36, that would also be a common multiple, and that's true. Okay? So, with the idea of the least common multiple, meaning the lowest one, that indicates the 12s would fit that answer. So the least common multiple of 4 and 6 is 12. Okay? So all I did was counted by 4s, all I did was counted by 6s, and the least common was that particular number of 12. Okay, so that's the kind of thing that you're going to be asked to do. All right, so let's go to example 1, where it says find the least common multiple of 6 and 8. So count by 6s. 6, 12, 18, 24, 30, 36, and there's probably more, right? And then 8. So we have 8, 16, 24, 32, and 40. We won't go any further because I think we found one. Okay? All right, what's the least common multiple here? There's no 6, there's no 12, there's no 18. There it is. It's 24. So the LCM of 6 and 8 equals 24. All right, pretty easy to find, and they're going to give other ways to do this. So let's say that we have it asks for the least common multiple. Well, that was a bad M. How about that? Least common multiple of 18 and 24. And then they ask to use prime factorization to find that. So what does that mean? So we're going to take 18 and we're going to factor it. Okay? Divide it by 2, you get 9. Divide it by 3, and you get 3. So 18 is 2 times 3, times 3. All right, then we're going to do 24. What is 24? Divided by 2 is 12, divided by 2 is 6, divided by 2 is 3. So we're going to say 24, 1, 2, 3 2's, 2, 2, 2, and then 3. All right, so how do you find this out? What is the answer to that? Okay, so let's circle however many 2's and 3's we have. Okay. If we have think about it this way. 24 has 3 2's, so we're going to take all of those. Okay, so 2 times 2 times 2. In other words, we're going to take the amount that has the most in it. And you'll notice that this one up here has two threes. So we're going to take times 3 times 3. Now, that number, when you multiply that out, you will get the least common multiple. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. 24 times 3 is 72. And that is our least common multiple. So, to find that, we had to use the one who had the most. Let's say that we had a 5 in here somewhere, okay? If there's something that has a 5, you would have to add that down there too, because if there's only one of it, you have to add it, okay? So this is a little more difficult than just factoring them, but still not too difficult. Example 4 says, instead of dividing 220 by 5, double both numbers, mentally calculate the quotient. All right. 220 divided by 5. We would typically do this, right? Oops. 220. And we would say 4, and we would say 20, and we would put that as 44. Okay, so listen to what the problem tells us to do. It says double both numbers and mentally calculate the quotient. So what's the double of 5? 10. What's the double of this? Well, it would be 440. And then if we just simply cancel off the zeros, guess what we're left with? Same answer. Okay? So 220 divided by 5, if we double it, cancel off the zeros, whoop, we get 44. And really what we're trying to do is getting this to something with a 0, like 10, because it's really easy to divide 10 into 440, and we get 44. We get the same number, 5 and 220, but it's easier to get it with mental math that way. Just a little trick to have you do that. Same thing, instead of, for example 5, instead of dividing 6,000 by 200, it says divide both numbers by 100 and then mentally calculate the quotient. Well, if we divide both by 100, basically we're canceling off those zeros. Well, what's 2 into 60? Well, it would be obviously 30. Okay, so it's just mental math, and I think you've seen some of those exercises before. Anyway, just something to acknowledge. All right, that's your lesson for today, lesson 27. Do well in it. If you have questions, come talk to me.